Hello once again. It became almost a tradition that most of my latest movies begin with the geomagnetic disturbances which are taking place recently over the northern hemisphere. This episode won't be different. Although geomagnetic pulsation wasn't as strong as the ones which were taking place couple months ago, local K index was elevated to 5 points. In Norway, the jolt was slightly stronger and reached around 500 nanoteslas at mid-latitudes. I think that you won't be surprised too much if I will show you the readings from Canada, where at the same time, around 21st UTC, only some minor disturbances were recorded closer to the polar cap. But on this side of the globe, much stronger instabilities of geomagnetic field took place couple hours earlier, around 6 UTC on the same day. Of course, at this time in Europe, magnetometers didn't record anything. I spoke about the local geomagnetic jolts many times before. In last couple years we can see them pretty often all around the globe. However, during last 2 months I've noticed that their frequency and strength is declining. But it's still too early to make any conclusions. I've almost forgot to mention about the fact that just like before, asolar wind readings didn't record anything what could explain the geomagnetic pulsation. Instead, there is a small gap in data, exactly at the same time when magnetometers in Europe started to freak out. Of course, you might say that it is caused by the coronal hole stream, which during the same day increased the solar wind velocity to 600 km per second. But in the case of fast solar wind, frontal density wave is much more geo-effective than the stream itself. But while the disturbances in Europe were not connected with space weather activities, at least according to official data, jolt recorded earlier in Canada is a different story. Although I'm not 100% sure if it is the main cause of those disturbances, just before they started, SWMF plus RCM magnetosphere simulations generated one of the weirdest images which I ever seen on those monitors. This image shows the impact of boundary between fast solar particles and the density wave in front of them. But I wouldn't call this event as typical one. Take a look at the bow shock and all those field lines which look like they were drawn by an artist with Parkinson's disease. But the Z-Cat monitor looks even worse. Looking from above, we can see that during the impact something what looks like a tumor or browser appeared on the eastern part of magnetopause. On the eastern part of magnetotail, plasma velocity vectors are directed towards the viewer. What means that this dense stream of particles was pushed through the current sheet from underneath. Y-cat view confirms it nicely. I can be wrong, but I don't think that magnetosphere should behave in such way. Huh. I think that I've just guessed a possible cause of this event. It seems that two extremely powerful IMF field lines merged into a single one right in the middle of magnetotail. But even after the magnetic reconnection, the upward directed plasma pressure remained strong. Last thing which is for sure worth to mention is the area of decreased plasma density which is visible next to the western part of bow shock. Notice that right next to it, the density of plasma is slightly elevated, what tells me that it might be a dipolar magnetic connection. I can even guess the direction of particles flow within this flux tube, and this can be a great help in finding the position of the low energy field source, whatever it might be. Field lines which connected with our planet during this event were strong enough to penetrate the dense layer of bow shock. Some of you know probably what I think about the existence of coincidence in the universe. I simply don't believe in such thing. Of course, I can be wrong, and the strong backside gusts of neutral particles which were taking place during the whole day of February 8 have nothing to do with the magnetosphere anomaly. Decide by yourself. The last time when I saw such strong backside pressure on this monitor took place in March 2012 and caused the event known as 2012 magnetopause reversal. This gas was as well strong enough to compress the entire magnetotail and squeeze the entire magnetosphere to the shape of a ball. But this is not the end of weird activity on radiation belt monitors. Around 1 hour before the anomaly took place, there was a strange burst of particles at 1 mega electron volts. During the rest of the day, density of electrons was constantly growing within the Van Allen belts. This is the good moment to speak a little bit about current problems with magnetic field of Earth. As you possibly know, our planet is right now experiencing great problems with the magnetosphere. What might be a sign of a possible magnetic polarity shift? Even people from NASA don't try to hide it anymore and tell that the possibility of pole shift is pretty high. But there are couple aspects which do not fit into the pole shift scenario. For example, it is known that before the magnetic poles will flip upside down, strength of geomagnetic field has to drop almost to zero. Of course, weakening magnetosphere is a well-known fact. However, the rate of depolarization is too small to tell that we're on the edge of a pole shift. If the rate won't change, it will take thousands of years for the magnetosphere to disappear. But all the signs on Earth and in heavens tell us clearly that we don't have so much time. Magnetic disturbances are gaining strength much faster than magnetosphere is weakening. Why? Because there is no official model which would include an additional factor, external force, which is the main cause of magnetosphere disturbances. Only if we will add such force to the space weather models, we will be able to understand the ongoing changes of our planet. To say it shortly, it's not the weakening magnetosphere, but the increasing strength of additional electromagnetic force what is causing all those anomalies. Another problem with the pole shift scenarios is the order in which the depolarization is taking place. According to current models, polarity flip is caused by the changes of Earth's inner currents within the planet's core. If it would be true, magnetic field would start to freak out before the changes would affect other aspects of our environment. Simply, we would see the flipping poles before the weather patterns would start to change. But instead, we are experiencing something completely opposite. Upper layers of atmosphere are affected much stronger than the geomagnetic field on the Earth's surface. My model explains it nicely. Because the changes are caused by an external force, they are affecting mostly the outer layers of our magnetic field. Low energy field won't be able to affect Earth's core until the currents of magnetosphere and ionosphere won't match with its own. So if the changes are caused by an external factor, weather patterns will start to change before the flip of magnetic poles. Bad side of this model is the fact that the biggest disasters will probably take place when low energy field will finally manage to establish a constant connection with the core of our planet. So, everything what we are seeing currently is only an introduction to the real events. But today I would like to move one step further. Pay attention, as I will try to connect magnetosphere simulations with actual satellite readings. Let's look at TIMI's data from the time when this disturbance was taking place, in the morning of February 8. However, first we need to ensure ourselves that the entire uncommon activity wasn't caused by an error, as there is not much on ACE readings what could explain those anomalies. Of course, according to SWPC data, there wasn't any space weather activity at this time. Even if both GOES satellites recorded a sudden compression of the plasmasphere. Everything becomes clear when we look at Canadian magnetometers plot, where we can see that the impact caused a pretty strong geomagnetic disturbances. First jolt was probably caused by the backside high-energy electron wave. The instability recorded soon after was most likely connected with the magnetosphere anomaly. Both events were recorded by all orbiting Earth TIMI's crafts. But not everything is so obvious while we compare CCMC simulations with actual readings from satellites. First thing which I thought about was checking if the current ring discharges can be confirmed by TIMI's satellites. Let's check the discharge from the day February 10th, which took place between 10 and 12 UTC. TIMI's crafts can be easily used to watch the condition of plasmasphere, Van Allen belts and current rings. Here we can see the spectral plot of ion energies. And here is the spectral plot of electron energy. But check how the plasmasphere looked like on first day of February. Nine days ago, there was much less energetic particles trapped within the inner magnetosphere. So, the particles didn't disappear after the discharge on February 10th. However, 2 of 3 satellites which orbit our planet recorded some kind of event at the time when current rings monitors were switched off. TIMI's P3 satellite recorded a sudden drop of low energy ions and a simultaneous inflow of electrons. P4 craft recorded something similar but less intense, while P5 didn't record anything, except some weird increase of density. And this is the right time to introduce you to another source of data. 2 Van Allen satellites, A and B. Compared to them, TIMI's satellites look like simple toys. Hard to tell how many measurements they are making, but for sure lot of them. For example, here we can see a sudden loss of high energy electrons around the time of discharge on current ring monitors. And on those monitors we can track the outflows of low energy protons, helium ions and most important for us, oxygen ions. Here we can see a sudden disappearance of protons at lowest energy bands, dark blue. Here it is visible even better. Sadly, big part of data is added with a pretty big delay, so I leave it for another day, because now I need to show you something else. Some time ago I promised myself to stop trying to find physical evidences of Planet X. All my previous efforts turned out to be mistakes. However, today I will forget about my promise. Looking for celestial bodies in the neighborhood of solar system is not an easy job. You need to compare different sky surveys and look for objects which change their positions in time. Just like this star, which can be seen in visible light spectrums. Its motion appears to be different than other stars in the background. Problem is that the sky is full of such objects and it's hard to point out any possible candidate for Planet X. Another good idea is to turn on the infrared surveys and look for the brightest objects on the sky. Aladdin, a free Java applet, allows to load couple images as layers. This IR survey was made by VICE satellite. And this is one of the brightest objects which can be seen on the VICE All Sky survey. When we compare it with other infrared sky surveys like IRAS or 2MASS, we might be surprised. Notice that except the huge object in the middle, other stars are placed in the same position on VICE and 2MASS images. In visible color range, there is neither nothing what could be a possible source of such strong IR light. But I went through all of this long time ago, and since that time I've learned a lot. Now I will use the coordinates from Aladdin to load this fragment of image into IRSA, online tool made to analyze VICE survey. This is how the object looks like in close-up. But the data which I'm interested in can be seen here. Those are the dates on which this part of sky was captured by the satellite. And now I can go to Stellarium and use this data to see if there was some object in this area which could be captured by VICE. When we will do it, it will become clear that at this time, right in the middle of screen, we can see the Jupiter. VICE satellite captured simply the heat of the biggest planet of solar system. But if it's not the Planet X, why I am showing you all this stuff? I wanted to use it as an example, because not too far away from the Jupiter, at coordinates which I will paste into description box, we can see another bright IR object. And just like before, it can be seen only on WISE All-Sky survey. Now I will make everything exactly the same as before. Effect is pretty similar to the image of Jupiter, but let's use the given time of captured in stellarium. This is the effect. To prove that I did everything correct, I will compare the positions of background stars in stellarium and Aladdin. I think that it's enough. Yes, both screens show the same part of the sky. But I think that those stars are the best to use them as a point of reference. In stellarium, there is nothing what could be a possible source of such strong heat. Okay, but there is a last chance. A second WISE survey of this region was made 6 months later, on 11th and 12th December 2010. Maybe we will find something at this time. But again, there is nothing. However, at this time Jupiter was placed much closer to this part of the sky. But not close enough to become a possible source of the IR light. If it would be the case, IR light source would be placed somewhere here. Besides, before it was visible on Vice survey in red color, not green as this object. Of course, I'm not sure if it is the actual planet X, but I think that it is interesting enough to be recorded. I'll wait and see what D5UNCR will say about it. For the end, I would like to show you how big is the concentration of most important greenhouse gases in the atmosphere. This image shows the total density of carbon dioxide. As you can see, the biggest air pollution is taking place in Central Africa. South from the strongest emission, density drops under the average level, what makes a clearly visible depolarity. Second monitor shows the total concentration of methane, which is a much more potent greenhouse gas. In the total column mode, the situation doesn't look so bad, but when we'll show the density on surface level, things are getting worse. Entire northern hemisphere is completely covered in methane fumes. Look out if you want to smoke a cigarette. You might blow the entire planet out. And this would be all for today. Enjoy the ride. Class dismissed. Be safe. Peace.